Warm good afternoon to all. This is the video about Brinell hardness. The Brinell hardness is a measure of hardness of a material. Typically, metals determined by the diameter of the indentation. In Tamil, we know as H, right? At the indentation made by a spherical indenter under the specific loads. It is the Brinell hardness number. It is one of the oldest and most widely used method for evaluating the hardness of the materials, particularly metals. This Brinell hardness value is obtained by dividing the load applied to a material by the surface of indentation, where in this formula we can see HB, which is the Brinell hardness value. It's load applied on the diameter of the spherical indenter and the diameter of the indentation that is made on the material. So this Brinell hardness test involves applying a constant load to a material surface using the hardened steel ball as indenter. The size of the indenter and the magnitude of the load applied are standardized based on the material being tested. So here the material which is being tested is what to say? The material is based on the material only. We are going to choose the loading time, loading magnitude, loading time, and what type of and the size of the indenter we are using. Okay, so this Brinell hardness testing offers several advantages, including simplicity, repeatability, and ability to test larger or rough specimens. However, it may be not suitable for very hard and thin material due to the potential for excessive indentation depth or surface deformation. The Brinell hardness value are commonly used in the materials testing, quality control, and the engineering design to assess the hardness, strength, and wear resistance of metallic material. They provide valuable information for the material selection process, optimization of material properties, and the performance evaluation at various industrial applications. This Brinell hardness test is typically works with this following steps. The first one is preparation of specimen. The material sample which is to be tested prepared by bichining or polishing its surface to ensure that it should be flat and free from defects or any surface irregularities. Second one is that selection of indenter and load. A hardened steel or tungsten carbide ball is selected as indenter. Here, one thing that we should keep in the mind is that always the indenter should be hard or should have high strength than the material which is being tested. So the indenter we are using is hardened steel or tungsten carbide ball is selected as indenter. The diameter of the ball and the magnitude of the load are determined based on the material being tested under the desired testing conditions. The common ball diameter may varies from 1 to 10 mm, but it is purely depends upon or how we are using depends upon the material, and the typical loading ranges from few kilograms to several thousand kilograms. It may goes up to maybe up to 8,000 or 9,000 kilograms, right? kgf we will say as kilogram force, right? So the third one is application of load. The selected ball is pressed into a surface of the material specimen under the predominant loading. This load applied for a specific period typically ranges from a few seconds to several tens of seconds to ensure sufficient indentation depth. So after removal of load, the indenter is retracted. After the diameter of the indentation left on the material by the indenter is measured by using specific optical or mechanical microscope. This indentation diameter is typically measured in millimeters. So the last one is reporting, and the Brinell hardness value is reported along with the corresponding ball diameters and applied load. And this Brinell hardness test has advantages because it provides a measure of hardness not significantly affected by the surface condition of the material, but it is suitable for testing a wide range of material, including those that are coarse-grained, rough, or highly heterogeneous. However, it may not be suitable for very hard material or thin specimens due to its potential for excessive indentation tips, right? That's all for today. Thank you and have a great day.